Hello, everyone. Mr. Hein is back. I hope you had a nice weekend and happy Monday. For this video here, we are going to talk about what is a function. Okay. Because last week you started already using function notation, the fx, but we didn't necessarily talk about what is a function. And that's what you're going to explore at the soda machine problem and those later problems. So we'll start with the definition and then we'll go from there. DEF apostrophe N is just my shorthand of writing definition. So a function means that for every input, there is only one output. All right. So for every one input, there's one output. And we'll look at this today from a table and a graph. So we'll do some table examples to show you what that might look like, and then some graph examples. Alrighty. So say I make a table and we'll say the input, and it'll be like your soda machine problem. So we'll say we'll call it the buttons, and your output will be the soda. All right, so we're gonna make a little table here for the first example. So let's say if you hit button 1, you get a Coke. If you hit button 2, you get a Sprite. If you hit button 3, you'll get a 7-Up. If you hit button, and there's another button 2, which will give Sprite. And there's another button 3, but this one gives Pepsi. All right. So if you look here, and the question says, is this a function? So is this a function? Well, you have your input 1 gets you a Coke. You push that button, a Coke comes out. You push button 2, a Sprite comes out, and that's fine. But button 3, you hit that, a 7-Up comes out. You hit 2 again. Now, a function means like a way you can think about a function is it's predictable. And that's why in math we care so much about functions, is that they're predictable. If I hit 2 again, I should get a Sprite. Do I get a Sprite? Yeah, so that's good. So that's not the issue. The issue is actually right here. If I hit 3 again, well, since I hit 3 and I got 7-Up, I should expect 7-Up. But did I get 7-Up again? No, I did not. So this right here is a problem. So this is not a function because the input of 3, right, if I hit that button 3, comma, had 2 different outputs. Right? And that's a problem, right? It's unpredictable. Unpredictable. If you hit button 3, you don't really know what's going to come out, and that's a problem. All right. Let's look at maybe 2 more examples. We'll do 3 total. So this is the first example. Let's do another function. We'll say button, and we'll do the candy this time because I think there's another problem in your work that's like this. So let's do button 1, 2, 3, 4. There's 5 buttons. You get Twix. What's another candy now? We'll go Snickers. I know there's a chocolate, it's not really candy, but that's okay. We'll go Nerds. Starburst. Let's put Starb. I hope you're listening and you know what I'm saying. And then the last candy we'll say is gummy worms. Okay. Is this a function? So let's see. So the way you look at it is, again, you look at every input. If I hit 1, I hit Twix. Do I ever hit 1 again? No, so that's fine. I hit 2, I get Snickers. Do I ever hit 2 again? No, that's fine. 3, is nerds, but do I ever hit 3 again? No. And if you don't ever have another input, then you don't even know if it's predictable or not. So you assume that it's working correctly. You assume that it's predictable because you have no way of determining that it's not, right? 4, but there's no other 4, so it's hard for me to determine if it's working poorly. And 5 gummy worms. So does each input have an output? Yeah, 1 has Twix, 2 goes to Snickers, 3 goes to Nerds, 4 goes to Starbucks, 4 goes to Starburst, and 5 goes to gummy worms. So yes, this is a function because each input only goes to one output. One output. Okay. So there's another example. Now this one's gonna get a little bit trickier. Let's look at this one. So let's say button, and we'll do candy again. Okay. This one, a lot of people miss every year. Let's go buttons 1, 2, 3, 4, 5. And what if they all gave Twix? What if they all have the same output, right? Because remember, typically the bottom row is the outputs, typically, and in this case that is it. Is this a function? Okay. Now remember the definition. Each input has one output. Does the input 1 goes to Twix? Does 1 always go to Twix? Well, as far as we know, yes, because there's no other 1s. 2 goes to Twix. It's okay that the outputs are the same. You can have more buttons that give you the same thing. The problem is, the question is, every time I hit 2, will I get the same thing? Yeah, because I never hit 2 again, so that's fine. 3 gives me Twix. Do I ever hit 3 again? No, so that's fine. 4 gives me Twix, which is fine because there's no other input of 4. And 5 gives me Twix, so that's good too. So in fact, the answer here is yes. This is a function because each input goes, or each input has one output. Yes, those outputs are the same, but remember, we're focusing on each, like the input at a time, not the whole system, and that's fine. They can have multiple buttons give you Twix, but if there's a button 1, if 1 ever shows up again, like if I add 1 here, if there's another button 1, what does it have to go to? It has to go to Twix, right? That's how you make sure that it's that keyword at the top, predictable. So yes, this is a function because each input has one output. Right. And then I'm going to do one more. Let's see if you can see this one. So let's do just X and Y. A little bit more abstract on this one. Let's go -2, -1, 0, back to -1, back to -2. So those are your inputs. And let's say you get 10, and then you get 8, and then you get 5, and then you get 8, and then you get 5 again. Is this a function? Well, the input 0 goes to 5, and that's fine. There's no other zeros. -1 goes to 8, and you have another -1, but does it also go to 8? Yes, so that's good. But look at the -2. -2 goes to 10. Like if I hit a button -2, it gives me a 10. But if I hit -2 again, is it giving me that same output? No, it's not. So this right here is a problem, right? So this is not a function because the input of -2 has 2 different outputs. Okay. So that's how functions make sense from tables. And I hope those 4 examples make some sense. Okay. Now, remember, you can pause the video, rewind as much as you can. If I'm going too fast, you want to copy this down or reference these. All right. Now we're going to look at some graph examples. All right. Now, graph examples. So an input, so the question is, what's an input on a graph? I mean, and what's an output, right, on a graph? So an input on a graph is typically the X, and the output on a graph are the Y values. Right. So let's look at this first example and make sense of it. So I'm going to make a little graph here. And let's say the graph looks something like this. So this point right here, your input, if I was to make a table so you can make sense of this input is -1 because these are your x values, right? X is left and right. So you have -1. And what's the output? And this is the y values. The output is -1. Okay? So that's that point right there. This one has an input of 0 because it's at 0 and an output of 0. And this one has an input of +1 and an output of +1. So if I was to make it a table, it would look like that. Now on a graph, if you didn't want to use the table, because from the table you're like, okay, I just know this. Each input is different. They all have one output. So yes, this is a function. But say you didn't want to use the table. Say you just want to use the graph. Well, when you find an input at -1, what you do is draw a vertical line down it. And wherever your graph is, it can only hit one time. And what I mean by hit/touch one time. Because that would imply that there's only one output. So notice at -1, I only hit one time. That's good. At 0, I only hit one time. That's good. At 1, I only hit one time. So that's good. So yes, this is a function because each input only has one output, and I'll put in parentheses on its vertical line, because that's really what inputs mean. Right? At -1, all of these are still -1, just possible different outputs. At 0, these are all 0 inputs, but there are possible different outputs, but there was only one that this graph showed up. Right? I don't know if that makes sense to you yet, so let's look at another one, and we'll look at a few more. Okay? So what if I looked at, say, a circle? My best circle possible, it's not bad. Is this a function? Right. We'll look at the input of 1. Okay. If I draw a vertical line down it, so at your input of x equals 1, how many outputs are there? Well, I hit one time here, that's an output. And I hit one time here, that's an output. So your one input has two different outputs. So this is not a function, since your input of x equals 1 has two different outputs. And I don't know if you've caught on yet, but the trick here is that something called like the vertical line test is what they use, which vertical means up and down, and a line because it's a straight line. And you test to see, does it hit only once? So let's look at two more examples, and I'm just going to write the answer down. So what if you had a curve like this? And what if you had, say, a C like this? Are these functions? Well, if I draw vertical lines, do I only hit once? If I draw that line, yes, I only hit once. At this input, if I draw a line, it only hits once. At this one, it only hits once. If this one, it only hits once. Here, it only hits once. Here, it only hits once. No matter how I draw a vertical line, it's only going to hit one time. So yes, this is a function. Over here, if I draw a vertical line, right away I can see that I hit 1, that's one output. And I hit a second time, that's a second output. So then you can see already that no, not a function, because this input has two outputs on it, this line at x equals 1. So x equals 1 has two outputs. Okay. So there it is. I hope that helps you understand what a function is from a table or graph. Rewatch this a few times, and if you ever need help, remember you can come to office hours. All right. Good luck on this assignment.